Hello friends, in this video we will see the force exerted by the jet of water on the stationary plates. I am Professor Dr. C.L. Ladekar from Pimpri Chinchwad College of Engineering, Pune. In this we will see the four different cases which is the force exerted by jet on the vertical plate. Then there may be the cases of the inclined plate. This is vertical plate, so jet is exerting force on the vertical plate. There may be the inclined plate like this, so that case we will see. There may be the curved plate where the jet is exerting the force at this center, and there may be the tangential entry from one of the direction. It is exerting the force. So we will see these four cases one by one. Very first case, force exerted by jet of water on stationary vertical plate. So let us consider a vertical plate. Let us consider the vertical plate. This is vertical plate which is fixed, and the jet of water which is moving with an velocity v. Jet is having the area A, is going to exert a force on the plate, vertical plate. What will happen if the plate is smooth and the impact is perfect? The water jet will get deflected in the direction of the plate. We'll see that. So as per the impulse momentum principle, rate of change of momentum in the direction of the force that you can calculate as the initial momentum minus final momentum. So that is the change in momentum, and here the momentum change takes place when the force is exerted for a certain time, fx into t, in that the change in momentum which is the initial velocity minus final velocity. So this time you can take it here, mass per second, okay, or mass per unit time into initial velocity. This is the velocity, okay, minus final velocity. Now rho a v, that is fx, because mass per unit time is fx rho a v, and initial velocity in this case is v. Final velocity in this case, when it is exerting the force, this is the velocity v. Is there any velocity in the x direction after impingement? No. So v is the initial velocity, 0 is the final velocity. So your expression for the force exerted by jet on the stationary plate will be rho a v square. Okay, if you want to calculate the force exerted by the plate on the jet, you can take the final momentum minus initial momentum, and then it will be 0 minus v, 0 minus v. So this will be fx will be minus rho a v square. So when it will be minus, when you want to calculate the force exerted on the plate by the jet, okay. Then we'll see the second expression, the second case wherein the jet is going to exert a force on the inclined plate. So this is the inclined plate which makes an angle theta, and v is the velocity in the x direction. So what happens if you want to calculate the velocity in normal direction, which is this one, this is the normal direction. So you can very well take this angle, because since this is theta angle made with this, you can say this is the sine component and this is the cos component. So this is v cos theta and this is v sin theta. So this is the velocity with which it will be impinging on the plate in the normal direction, And if you want to calculate the force in normal direction, how you will say, or how you will note down, fx is equal to, again, in place of fx you can say fn, that is force in normal direction. Fn is equal to rho av into initial velocity is v sin theta, minus what is the final velocity in that direction, 0. So you can write the force in normal direction, that as rho a v square sin theta. And then since this is the theta angle, okay, this normal directional force is going to make angle, okay, with this. If you drop the perpendicular, you can say this is theta, This is 90 minus theta. This is again theta. This is again theta. So you can say this is suppose this is Fy, and this is Fx. What you will say? Fx is equal to this is cos theta, this is cos 90 minus theta. So Fx is equal to Fn cos 90 minus theta, and Fy is equal to Fn cos theta. Okay, that we'll see in the expression. Same thing is mentioned here. You can take the force in normal direction, which you can calculate that as rho a v square sin theta, because v sin theta is the velocity in normal direction and final velocity in the normal direction is 0. So Fn is equal to rho a v square sin theta. And if you want to calculate the Fx, that is force in normal direction, x direction, it is making an angle cos 90 minus theta with the, Fn is making cos 90 minus theta with Fx. So this is Fx, and this is your Fn. How much is this angle? It is 90 minus theta. So this makes cos angle of 90 minus theta. The Fn makes an angle cos 90 minus theta. Cos 90 minus theta is again sin theta. So you can write rho a v square sin theta into sin theta, that is rho a v square sin square theta. And similarly for Fy, that is force in y direction, this one, you can write Fn sin 90 minus theta. So this will make an angle 90 minus theta, which is sin angle. This is cos. And therefore this you can write Fn cos theta, which you can write further rho a v square sin theta into cos theta. So if you see the Fx and Fy, one is rho a v square sin square theta and another is rho a v square sin theta cos theta. You can very well calculate the resultant force, which will be the summation of Fx by Fy by Fx, and you can calculate the direction of the resultant also. Then we'll see the third case, that is the force exerted by jet, which is striking at the center of the stationary curved plate. So this is the stationary curved plate on which the jet is exerting the force at the center and is going in the direction of the plate, which makes an angle theta with the horizontal. So this component becomes v cos theta and this becomes v sin theta. So in this case, we'll use certain notation. One suffix stands for the inlet condition, 2 stands for the outlet condition, x stands for x directional and y stands for the y directional. So if the jet strikes smoothly and there is no loss of the energy, it will come with the same velocity v in the direction of the plane, and therefore component of velocity perpendicular to the jet will be v sin theta. If you see here, this is v sin theta, so this is the perpendicular to the jet and this is parallel to the jet, v cos theta. Now the force exerted by jet Fx, you can very well write that is mass per second into the initial velocity minus final velocity. So what is the initial velocity? If this is the curved plate and this is v, this is the initial velocity v, and what is the final velocity? This is the final velocity, which is v cos theta. But since the direction of the velocity initial is from left to right, final velocity is right to left, so you can consider this as minus sign, and minus becomes plus. So this is minus and this is minus, so it becomes rho a v square into 1 plus cos theta. Similarly, Fy you can calculate this mass per second into initial velocity in y direction and final velocity in y direction. Is there initial velocity in y direction? No, there is 0 velocity in y direction, but in y direction the final velocity is equal to v cos theta, and therefore v sin theta, and therefore you can write rho a v into 0 minus v sin theta. So it becomes minus v cos theta, that becomes rho a v square into sin theta, rho a v square into sin theta. Is it clear? Because Fy is equal to rho a v into initial velocity 0 and final velocity is minus v sin theta. So minus, this will be minus rho a v square sin theta. So if you consider the direction from bottom towards top, you can take this as a positive direction, but if you take it in opposite direction, you can say it is rho a v square sin theta also. Okay, now we'll see the last expression, that is the force exerted by jet on the stationary curved plate when the jet is exerting the force tangentially at one of the end of the plate and plate is symmetrical. If it is symmetrical, then the expression will we can calculate. If it is asymmetrical, then in that case also we can calculate the expression. So when it will be going with an velocity with angle theta with the horizontal, you can resolve the component into v cos theta and v sin theta, and it will be coming out with the velocity of the same velocity in the same direction as that of the plate. So this is theta angle again, since it is symmetrical, this is v cos theta and this is v sin theta. Only the difference is this is v cos theta, this is v cos theta, this is going from right to left, this is going from left to right. Okay, then if you want to calculate the force in x direction, you can calculate mass per second into initial force velocity in the x direction minus final velocity in the x direction. What is initial velocity in x direction? If you consider from left to right as a positive direction, since it is going in the opposite direction, that is right to left, you can consider negative sign. So v cos theta minus of minus v cos theta, that becomes 2 rho a v square cos theta. And if you want to calculate the Fy, that is force in y direction, again the initial velocity in y direction v sin theta, final velocity in y direction, that is v sin theta. So that becomes 0. In this case Fy becomes 0. Fy becomes 0. If the plate is asymmetrical, only changes will be in this. Okay, only changes will be in this. I will note down here the expression when it is asymmetrical. Fx, you can write rho a v square into cos theta plus cos phi. Here you can see cos theta plus cos phi, and here sin theta minus of sin phi. So that much changes you can brought into, and if the problem is there, you can solve for the forces of the jet. With this, I thank you very much for this. Thank you.